preparation of this Bacolite. Okay, yesterday hope you have realized that it's a thermoset plastic material, and this thermoset plastic material is strong, rigid, brittle, and has umpteen applications. There we chose that of the Bacolite, which is a copolymer of Bacolite is a copolymer of
Phenol and
61
formaldehyde.
phenol and formaldehyde. Correct. Roll number 61 is present.
Yes, ma'am. 61 is present.
Oh, you know the answer?
Ma'am, I got breaks in your voice, ma'am. Can you ask me again?
I was asking, will you give me the answer or you will sing me a song?
I didn't get question properly, ma'am. If I know
Okay.
answer, I'll tell, or else I'll try singing one song.
Okay. Memorize nice songs. If not, your friends get bored. Okay. I think
Okay.
others also are also waiting for a chance to sing me a song. Okay. And I'll get back. Actually, there's a drive at our college, vaccination drive. So we are just going there to get vaccinated. So I've like preponed the session. Okay. So uh, what we are trying to discuss here is, yesterday I have told you there are 3 steps in making of this Bacolite, which is phenol formaldehyde resin. Okay. Because 2 monomers are present, a copolymer is obtained. What you should remember here is that it's a condensation polymerization reaction where the functional groups are combining to give the product. Okay. So what you have seen, like in nylon 66, it was condensation polymerization between acid group and amine to form amides. Okay. So was in Kevlar. In Kevlar, the 2 monomers are 1,4-diaminobenzene and terphthalic acid. Benzene with acid groups at 1,4 positions. Okay. And Kevlar is also called aramid, and it's a very strong polymer. In fact, the base material or fiber used for making bulletproof jackets or bulletproof anything. Okay. Cars nowadays there are shields, bulletproof shields and all. The base material goes with Kevlar. Okay. Whereas in nylon 66, the fiber again very well known. Again, it's a copolymer of hexamethylene diamine and adipic acid, wherein adipic acid provides the COOH groups, whereas the diamine, hexamethylene diamine, is another monomer which provides NH2 groups. Again, a polyamide is formed during the process. In the preparation of these 2 polymers, you'll always have condensation polymerization reaction. Generally, not much catalyst is dictated there because they are relatively fast reactions only. The other one, what we discussed yesterday, was that of PVC, polyvinyl chloride, where a single monomer is combining to form the polymer. So the polymer is a homopolymer, a polymer which is having only one monomer. Whereas nylon 66, Kevlar, this Bacolite are all copolymers. So what are copolymers? Involving more than one monomer. Okay. Yesterday we have seen that while making PVC, it's a addition polymerization reaction. Okay. And addition polymerization gave, using the radical initiators, gave the polymer, which is a homomer. Again, we started discussing about the making of Bacolite, which is again a copolymer of phenol and formaldehyde. And I've already explained to you all that this copolymer is prepared by taking phenol and formaldehyde, and the reaction takes place in 2 medium. That means it is catalyzed, as I've told you, in condensation polymerization. Catalyst dictates the rate of polymerization. Okay. So what you'll understand is that the polymerization of phenol and formaldehyde depends upon two conditions. What are those conditions? The first condition being whether the medium is acidic or it is basic or alkaline. That's one condition which dictates the polymerization of phenol and formaldehyde. So polymerization of phenol and formaldehyde is dictated by two factors. One is the medium. This is the medium. Okay. What's the other factor that dictates, that is whether it is acidic medium or an alkaline medium? The other factor that dictates the polymerization is P by F ratio. What does that mean? P by F ratio. P by F is the phenol formaldehyde ratio.
Not visible, ma'am.
Huh? Now are you able to see the board clearly? Okay. ఏం చెప్పాను? Polymerization of phenol and formaldehyde ఏంటి? Condensation polymerization. ఈ condensation polymerization two factors మీద డిపెండ్ అయి ఉంటుంది. ఒకటేంటి? కండిషన్ మీడియం అన్నమాట. అంటే అసిడిక్ మీడియమా బేసిక్ మీడియమా? ఎందుకు? Polymerization is catalyzed by either acid or a base. ఓకే, అదొకటి. ఇంకోటి ఫినాల్ ఫార్మాల్డిహైడ్ రేషియో కూడా డిక్టేట్ చేస్తుంది పాలిమరైజేషన్ ని. ఓకే, సో the discussion. And the polymerization takes place in how many steps? Em cheppanu. First step is addition of CH2OH group from formaldehyde onto the phenolic ring. Okay, the phenolic ring, what is the functionality of phenol? Yesterday I have told you. What is the functionality of phenol? 61.
3, ma'am.
3, ma'am.
3. Why? 2 ortho positions and 1 para position. Okay. So the functionality of phenol is 3, and at these 3 positions, this formaldehyde molecule can add on. Okay. And the functionality of formaldehyde is 2. That's the first step. In the second step, the added this group gets added onto the phenolic ring to form methylolphenols. Okay. That's what we'll study. This is a quick brief up of what all we have studied yesterday. So these methylolphenols undergo condensation again to form a linear, soft, flexible polymer called as novolac. These are famous again. These novolacs are further subjected to heat treatment called as curing. That means temperature, pressure. Okay, at around 60 to 80 degrees centigrade, they do this curing process in the presence of reagent like hexamethylene tetramine, like the urotropine, okay, which provides further formaldehyde molecules to form, on curing, will form the bacolite. This is linear, this is cross-linked structure. Okay, so these are the 3 steps that are involved in the polymerization process. Okay, so this overview yesterday I've already told you. Okay, so let's just brief up with the preparation of the polymer. So what's any doubts still here? I'll proceed. Right, now the next one is, right, step 1. Formation of methylolphenol. Formation of methylolphenol. Formation of methylolphenol. I have case 1. What is the first case? If P by F ratio, P by F ratio is less than 1 and acidic conditions. No, this is what is the symbol? Greater than 1. Huh? P by F ratio greater than 1. P by F ratio greater than 1 is right. That's a symbol, correct? That is, I want to tell that phenol is more and formaldehyde is less and conditions are acidic. That's a case 1. Okay. So what will happen because phenol is more, okay, formaldehyde molecules are less. Okay, then what will happen? Substitution takes place only at one position. Okay, why? Because more phenol molecules are there, less formaldehyde molecules are there. So only mono-substituted phenols are formed. At the most, di-substituted. But generally, it's a formation of mono-substituted phenols. If phenol formaldehyde ratio is greater than 1, phenol is more, formaldehyde is less, and conditions are acidic. Phenol, onto the phenol, this formaldehyde molecule acts on by condensation. Okay, conditions are acidic. You will put H plus. Okay, it will result in the formation of orthomethylolphenol or para-methylolphenol. Para is more in number. Orthomethylolphenol, and there's one more substitution at para position because of steric convenience, less steric hindrance. Para-methylolphenols are also very commonly formed. So, phenol substituted with CH2OH group is called as methylolphenol, para-methylolphenol. Okay, what you'll write? Since phenol is in excess, than formaldehyde, mono-substituted products are formed. Mono-substituted products are formed in excess. Products are formed in excess. Okay, so that's a point you want to convey. Fine. No. If then the next one is, did you write this? Okay, next one, case 2. What's the case 2? If phenol is less than formaldehyde. Okay, that means phenol formaldehyde ratio is less than 1. Phenol takku undi, formaldehyde ekku undi. So it will be less than 1. So this will be the sign, correct? In basic medium. And in basic medium. So what's going to happen? What do you see? Huh? More than one substitution is possible in this case. So what will happen? Just check it out. This is phenol. More than one substitution is possible. So phenol reacts with 2 formaldehyde molecules to form di-substituted phenols like this. OH, just put one CH2OH at ortho and the other one at para. Is the board clear? Now it is called dimethylolphenol. It's called dimethylolphenol. Okay. Now, if 3 molecules are added, 3 formaldehyde molecules are added. Now, it results in a tri-substituted phenol. That means a phenolic ring with 3 CH2OH groups. CH2OH, CH2OH, and CH2OH. So this is called trimethylolphenol. I hope you have written this clearly. You want me to write it again? But then that's the one. Trimethylolphenol. Okay? Easy? So this is actually, this methylolphenols are the starting compounds for the polymerization. Okay? All till right. Since, I'll just rub this away. Since, for case 2, since phenol is less than formaldehyde, di and tri-substituted methylolphenols are formed. Since phenol is less than formaldehyde, di and tri-substituted products are formed. Easy, very easy. I think once you just put your head in this and do it, that's it. You can write straight away in your examination. Not at all a tough task at all. Okay? That's the trend of most of the ECE students, that they write it such a way that they're almost geared up for the exam. That's it. They give a browse and they have the capability. I hope you too nurse the same. You can. That's what I want to tell you. Okay, I'll get back. Now, I'll talk about step 2. Step 2, formation of novolac or resol. Formation of novolac or resol is the second one. Is the board clear? Hope you are able to have a good view of what all I am writing. Okay? Fine. So just check. What will happen? I'll take up the monomethylalphenol. This is a phenolic ring and I chose CH2OH. This is called monomethylalphenol. Okay, just excuse me, this is correct. On to the top of this, put case 1. Acidic medium, P by F ratio greater than 1. P by F ratio greater than 1. Okay. Monomethylalphenol is formed in step 1. This undergoes condensation with one more molecule. Okay, there is removal of water, H2O. Please check what is reacting here. These two are reacting. Minus water to form methylene mediated CH2. Here, benzene. Hope you are catching up with me. CH2 like that. This group is n number of times. This is called Novolac. Okay. You have methylene mediated phenolic rings. Methylene mediated phenolic rings. అమ్మా అందరికి అర్థమవుతుందా? సో ఫస్ట్ స్టెప్ అయిపోయింది. సెకండ్ స్టెప్, ఫస్ట్ స్టెప్ లో ఏమైంది? ఫినాల్ రేషియో, యూ కీప్ రైటింగ్, ఐ షల్ జస్ట్ ఎక్స్ప్లెయిన్. ఏమవుతుంది? ఫినాల్ ఫార్మాల్డిహైడ్ రేషియో చాలా ఇంపార్టెంట్. ఫినాల్ ఎక్కువ ఉండి ఫార్మాల్డిహైడ్ తక్కువ ఉంది అనుకో, ఏమవుతుంది? ఆబ్వియస్ గా ఫినాల్ ఎక్కువ ఉంది కదా, ఒకటే బెన్సిన్ మీద మోర్ నెంబర్ ఆఫ్ ఫినాల్ ఫార్మాల్డిహైడ్ మాలిక్యూల్స్ యాడ్ అవ్వవు. అప్పుడు ఏమవుతుంది? జనరల్ గా ఒక ఫినాల్ మీద ఒకటే ఫార్మాల్డిహైడ్ మాలిక్యూల్ యాడ్ అవుతుంది. కండిషన్స్ ఎసిడిక్ ఉన్నాయనుకోండి, అప్పుడు ఏమవుతుంది? ఈ మోనోమిథైలాల్ ఫినాల్స్ ఫామ్ అవుతాయి. ఇదే స్టెప్ 1 లో. ఆ మోనోమిథైలాల్ ఫినాల్స్ ఎలా కండెన్స్ అవుతాయి? ఒక్కొక్కసారి OH of this CH2OH will condense with hydrogen of the benzene. అప్పుడు ఒక లీనియర్ సాఫ్ట్ ఫ్లెక్సిబుల్ పాలిమర్ ఫామ్ అవుతుంది, నోవోలాక్, కంటైనింగ్ methylene mediated phenols. or ఇంకోటి కూడా అవ్వచ్చు. ఓకే, OH, CH2OH, this is monomethyl phenol again, plus one more such structure, CH2OH. Okay, again minus H2O. What will happen? I'll get a structure like this. Here is a benzene. Okay, and OH, CH2. Okay, this CH2O, O, CH2 from this, and you have the phenol. This has methylene linkage. This has methylene linkage. This has etheral linkage. ROR is ether. Etheral linkage, which is possible actually in the case of case 2. Okay, etheral linkage. This is called resol. This is called resol. Okay, this is generally in the case of case 2. This is case 2. When medium is alkaline, and phenol formaldehyde ratio is less than 1. Okay, you can also write one more structure here like this. I can reverse. OH, okay, CH2OH, CH2OH, okay, minus H2O. Again, it will be the same structure. It is OH is in the reverse direction. Get it? Hello, hi. You hope everyone is understanding or writing. I am writing my notes. అర్థమైందా అందరికి? Just raise your hand by chance you didn't understand or you have some doubt. Okay, and this is resolve. Okay, now shall I rub the board? Okay, now this step 3. In step 3, it's the same small thing that keeps happening. Say step 3, formation of bakelite. Formation of bakelite. How it will happen? What you'll write? Novolac. Okay, during fabrication or molding. Fabrication or molding in the presence of hexamethylene tetramine. Hexamethylene tetramine will form bakelite. Okay. Curing temperature is around 60 to 80 degrees centigrade generally. Okay. What will you write? The structure of Novolac is this. It's a simple linear polymer. OH, CH2, OH, like this. The structure can be otherwise, but you can write for convenience like this. Now, which group is getting repeated? Let's say a group repeat out on the E group. CH, OH, రెండు OH లో మధ్యలో ఒక methylene. Okay, this is N times. That is Novolac. Okay. Hexamethylene tetramine. Will give Bacolite. Can you now write the structure of Bacolite? Yesterday I've already explained it to you all. What's the structure of Bacolite? I'll take, for example, 3 benzenes, okay, mediated with CH2. Ante oka Novolac ring. This is one Novolac ring structure. Okay. I'll write a mirror image of this Novolac structure again. Mirror image means just opposite. With 3 carbons, three rings for convenience. Okay. Then what I've done? I've attached these 2 rings with CH2 groups. That's the structure of Bacolite. That is Bacolite. I hope you got confidence. Okay. Just right. You're getting bored. I'll finish quickly now. Just 20 minutes అయింది క్లాస్ స్టార్ట్ చేసి అందరు ఇంకా కోపం వచ్చి వెళ్ళిపోతున్నారు. నెట్ ప్రాబ్లం వచ్చేస్తుంది. సాటర్డే అండ్ సండే ఆర్ లైక్ they are supposed to be leisure times. But that's for old people. I think you're not that old to take rest. You're young and energetic, and your skill has to be proven now. Okay, I'll get back. Fine. Now I'd like to tell that this Bacolite formation is taking place in the presence of hexamethylene tetramine, which is providing formaldehyde molecules during the molding process. Okay, so write that point. Right. Novolac is a linear. Novolac is a linear, soft, flexible polymer. Linear, soft, flexible polymer. It is linear, soft, flexible polymer. When cured, C-U-R-R-E-D, when cured in the presence of hexamethylene tetramine, when cured in the presence of hexamethylene tetramine, cured in the presence of hexamethylene tetramine, forms Bacolite, which is hard, rigid, brittle, cross-linked polymer, hard, rigid, brittle, cross-linked polymer. Okay, or you are going to write one more point out there. Okay, or you'll write during molding, hexamethylene tetramine provides the required formaldehyde molecules. During molding, hexamethylene tetramine provides the required formaldehyde molecules for cross-linking. Okay, then quickly we'll talk about the properties.
Repeat once again, ma'am.
Provides formaldehyde molecules for cross-linking. అంటే ఈ గ్రూప్స్ కోసం. Okay. Now properties. We'll quickly jot down few. First one, thermoset plastic, hard, rigid, brittle, brittle, first point. Non-infusible అంటే మెల్ట్ అవ్వదు. ఓకే, infusible, chemically resistant, chemical and corrosion resistant, scratch free material, scratch free material. Next, excellent electrical insulator, excellent electrical insulator. That's the reason why it's being used for plug boards, switches and all. That's the material. Okay. Next, resistant to acids, but attacked by hot alkalis, due to the presence of OH group. Okay, these are the important properties. Fine, right. Next, uses or applications. Okay, or applications. What else? What's the first point you can say? Put it on. Application enti? Used for making switchboards, plugs, and electrical equipments. Used for making switches, plug boards, and electrical components. Next, used for making components for telephone parts, TVs, radio cabinets, etc. Used for making telephone parts, TV, radio components. Okay, next. Novolac is used as an adhesive or sealant. Novolac is used as an adhesive or sealant. Sealant అంటే అర్థమవుతుంది కదా ఎలాగా నువ్వు రెండు సర్ఫేసెస్ ని సీల్ చేయాలనుకో ఏం చేస్తావు నువ్వు గ్రీస్ పెడితే రెండు పర్టికులర్ గా మన అదే ఆటోమొబైల్లో వాటిట్లో ఏం చేస్తాం గ్రీస్ పెడతాం కదా అంటే ఏమవుతుంది రెండు అతుక్కుపోతాయి గట్టిగా గ్రీస్ పెడితే సో దానికి నోవోలాక్ చాలా బెస్ట్ మెటీరియల్ ఇండస్ట్రియల్ సీలింగ్ ఓకే సో ఇట్స్ అ sealant. Novolac is a sealant in most of the cases for grinding wheels. Novolac is a sealant or adhesive for grinding wheels. Next, right. Also used in paints and varnishes. Akkade also used in paints and varnishes. Enduku ఇప్పుడు నువ్వు గోడ మీద పెయింట్ వేస్తున్నావు యూఆర్ పెయింటింగ్ ఎ వాల్ ఫర్ ఎగ్జాంపుల్ నౌ దట్ పెయింట్ హ్యాస్ టు స్టక్ ఆన్ టు ద wall, is it not? Okay, then I have a question. When the paint will struck more, if the surface is very smooth or little hard, or I'd say little
Rough.
not very smooth, I'd say. అదేంటి వర్డ్ గుర్తు రావట్లేదండి అదే కొంచెం రఫ్. When the surface is rough or very smooth. ఏంటి? When the surface is smooth or harsh, rough. When the surface is rough, only then the paint would stuck to the wall. The wall should be actually little bit rough so that the paint gets stuck more. And now the paint has to stick onto the walls, for example. అప్పుడు ఏం చేయాలి? ఒక gummy material యాడ్ చేయాలి కదా. So one such gummy materials can be this Novolak material. Materials like that. Okay, so is the application. Right? Next used as a resin for softening of water. Used as a resin in softening of water. Actually, cationic resin is an exact word. This will study in the water topic. Now the next heading is third one, rubbers or elastomers. Elastomers are nothing but synthetic rubbers. Okay, so what are these rubbers? Polymers having very good elasticity. Very good elasticity are called rubbers. Now what it means by elasticity? What it means by elasticity? Come on kids, what it means by elasticity?
When they regain its original shape after stress is applied.
When stress is applied,
it stretches and regains its original position, shape.
Okay, Kirti. Now you want to tell that elasticity is a property in which the polymer undergoes physical deformation when stress is applied. And when stress is released, the polymer regains back its original shape. The property is called as elasticity. Now, why do you think these polymers will have elasticity? Why? Because of their structure. So what you'll say, elasticity, right? Elasticity is the property in which of the polymer in which when physical stress is applied, the polymer undergoes elongation. To twice or thrice its original length. The polymer undergoes elongation to twice or thrice its original shape or length, but regains back its original shape when stress is released. Okay. Next dot. Elasticity is due to the coiled structure of the polymer. Elasticity is due to the coiled structure of the polymer. The coiled structure will make the polymer elastic. Okay. So this is the shape of the polymer. Polymer in coiled shape. Okay. When stress is applied, and this is amorphous in state. Okay. And when stress is applied, it undergoes uncoiling, uncoiled structure, and it is crystalline in nature. Crystalline, making it rigid. Okay. Crystalline, uncoiled structure. When stress is released, they get back to the original shape. So that's how the property of elasticity comes into the picture. So whenever, otherwise the rubbers we know, they are very tacky. Tacky ante ఇప్పుడు జాయిన్ అవ్వద్దు. అటెండెన్స్ ఒకవేళ నాకు కోపం వచ్చి తీసుకోకపోతే నో ప్రాబ్లం. విన్నవాళ్ళు విన్నారు, వినని వాళ్ళు ఓకే, నో ప్రాబ్లం. డోంట్ బ్రేక్ యువర్ హెడ్ ఫర్ అటెండెన్స్. ఓకే, సరే. ఈ మాట ఎందుకు చెప్తానంటే, ఐ కీప్ టెలింగ్ దిస్ అగైన్ అండ్ అగైన్ బికాస్ I want to always appreciate kids who are zealous to listen to a lecture. Okay, so always the preference would obviously go to them instead of kids just joining for attendance. Now I'll get back. Now, how the property of elasticity has come into the picture? Why not for fibers? Fibers are the stress deformation over. They don't undergo any physical deformation because of stress. That's the reason why if I just fold this cloth, okay, like this, now this is fiber, no physical deformation when stress is applied. But plastics undergo permanent because they are already slightly crystalline in structure. These are highly amorphous compounds. They are always in the coiled state. Okay, and when uncoiling is taking place, when stress is applied, recoiling would take place when stress is released. So they get back to their original shape. That's the reason why rubbers are very tacky. In fact, it's not a common experience for us. First law, the rubber, black rubber or gaskets or whatever you see, if they are put into high pressure, they become really hard. Okay, is it not common experience for all of us at home that when you take a cooker gasket, for example, initially it is a soft flexible material. Because of repeated heating and cooling on that gasket, now what would happen? It becomes really hard. Sometimes when you talk about a few rubbers, what will happen? They become sticky if you leave like that in hot. Okay, what will happen? Our rubbers are such that if you really apply pressure and you just press them together, okay, they become into one. That property of two rubber lumps, just by applying pressure, we can make it into one ball. That property is called as tackiness. Okay, all this is because they are very, very amorphous in nature. Why the amorphous nature of these rubbers? Because of their coiled shape. That's what I was trying to tell you. That means when you are doing polymerization, the end product can be a long thin fiber, or it can be a rigid material, little rigid material like the plastic, or it can be highly amorphous material like this, which can be a rubber. Depends upon the starting compounds and the type of polymerization you are taking up. Okay, now I'll get back to the next point. What you have in your syllabus, this is about the property of rubbers. Okay, hope you understood why the elasticity of these polymers. Okay, I have a question for you. Is it our rubbers are used as sealants? Can we seal? Okay, can you put the lid of your cookers without gaskets? Is it possible? No. What that ring of rubber is doing? It's doing the sealing activity. Okay, and of course they find umpteen application. In fact, the tires of the automobile industry are the best examples of composite materials in today's world. Engineering marvel in itself altogether. So that's an introduction to rubbers or elastomers. In fact, rubbers are natural rubbers and synthetic rubbers. Okay, and I'll just give a small introduction and just I'll move to what's there in the syllabus. So rubbers are of two types. One is a natural rubber, what we obtain from plants. Usually natural isomer is cis, but trans are also there like a tupacha rubber. Otherwise, cis is common. Okay, natural rubber like trees like Hevia brasiliensis and all will have natural rubber. Natural rubber has a monomer called isoprene. Is from isoprene. Generally cis, but it can be trans in some plants. Okay. The other rubbers are synthetic rubbers. Other rubbers are synthetic rubbers, also called as elastomers. And they are generally made by copolymerization. They are obtained by copolymerization process. Okay. That's what I want to just give an introduction. Okay. Now, the structure of isoprene. This is little important because I want to tell one point as an introduction and just go ahead. Isoprene is nothing but 2-methyl 1,3-butadiene. That's the chemical composition, and its structural elucidation was done almost nearly to the end of the First World War, and its application came for the manufacturing of synthetic rubbers during the Second World War time. Okay, umpteen number of synthetic rubbers were made during the Second World War time by copolymerization process. So 2-methyl 1,3-butadiene is a structure. So buta means how many carbons?
4.
4. Now can you write the structure? 1, 2, 3, 4 carbons. Okay. Diene means how many double bonds? Diene means how many double bonds?
2, ma'am.
2. At what positions? On
1
first
and 3.
carbon and third carbon. So I'll take this as 1, 2, 3, 4. So between first and second carbon, one double bond, and between third and fourth carbon is another double bond. And on the second carbon, I have methyl group. So CH3. Now rest all I would satisfy with hydrogens. Please check whether I am writing it correct or not. 1, 2, 3, 4. So that's the structure of 2-methyl 1,3-butadiene. Now I have a question for you. What is its functionality? Please tell me the functionality of this. Hello. What it means by functionality?
Number of binding sites.
సరే ఇప్పుడు దీని ఫంక్షనాలిటీ ఎంత?
2, ma'am.
అవునా అజయ్, will you sing me
Yes,
a
ma'am.
song? కాదు, 2 ఎలా చెప్పా?
I know
ఎన్ని
it,
pi
ma'am.
bonds ఉన్నాయి? How many pi bonds are there?
2 pi bonds.
Then how you are saying that it is 2? Each pi bond gives 2 sides kada?
Yes, ma'am.
మరి అప్పుడు ఎన్ని ఉండాలి?
No, ma'am. One pi bond will shift to form sigma bond. How can one pi bond shift to form?
Okay, I'll tell. Now, can anyone explain me what Ajay has told. No, today he doesn't want to sing a song for us. So he's answering the question diligently. Huh. Who else can explain? So he wants to tell, in spite of having two pi bonds there, which can have functionality 4, 2-methyl-1,3-butadiene has functionality 2. Why? Because of the rearrangement of the pi bonds in such a way that only first carbon and fourth carbon will undergo polymerization, and one pi bond shifts to the second and third carbons. So what will happen as soon as the bond breaks between these two, there are dots on all the 4 carbons, okay, free radical. And these two, second and third carbons, will actively participate in forming the pi bond at the center, whereas the first carbon and the fourth carbon are involved during the polymerization. So when isoprene is undergoing polymerization, okay, so what will happen? Polymerization, the first and fourth carbon are participating during the polymerization, and hence the addition is called as 1,4 addition to form the natural rubber. Polyisoprene, that's an exact one, to give polyisoprene. Polyisoprene, that's a structure. Okay, so is the polymerization. I hope you understood. Why I made you listen to this is because the functionality of these butadienes is always 2. Though they have 2 double bonds in the monomer, still one double bond will just move to the second end carbon, and the first and fourth carbon will get involved in polymerization. And hence the type of addition is 1,4 addition, okay, to give the polyisoprene, which is nothing but the natural rubber. Okay, now how they will represent this? Easy representation is like this: 1, 2, 3, 4 carbons. Okay, one double bond here, one double bond here. That is 2-methyl-1,3-butadiene. Okay, and we know that rubbers are subjected to dash for having more engineering properties. Rubbers are subjected to what process? For increased activity. Class is sleeping? Enti? Na question ardhamainda? Rubbers are subjected to what process? For
Sulfur
increased
adding.
sulfur adding.
Vulcanization.
Vulcanization.
Oh, lovely. That's a word. Vulcanization. Okay, correct. Everyone is correct. Addition of sulfur. Okay. Why addition of sulfur? Because the story now will unwind. In the elasticity allows the chaptunan. This is 2-methyl-1,3-butadiene. It underwent polymerization by 1,4 addition. 1,4 addition polymerization, and write it here in the center. Okay. It's for your know-how. These are the terms I keep using for explaining the polymer. So what I would like to tell, that 1,3-butadiene has underwent polymerization. 2-methyl-1,3-butadiene has underwent polymerization to give a polymer like that. Okay. So this carbon has got connected to another carbon like this. This is cis. Okay. This is taken n times. That is natural rubber. So what you are finding, because of presence of double bonds, the compound is still amorphous in nature, very much amorphous. Okay. Now to make it some just like pure iron. Is pure iron an engineering material? No. What is added to make iron an engineering material? What is doped? Carbon. Okay. What is doping? Addition of small amounts of other compounds uh, to increase its mechanical properties or some physical properties. Is nothing but doping. We might have studied about p-type doping, n-type doping in semiconducting materials. Am I right? Correct? So, like silicon, germanium and all, they take the semiconducting materials and add various reagents, okay, to make them more and more conducting. So what is doping? Doping is addition of other compounds to increase some properties, physical properties. Here I want to increase its mechanical properties. What I'll do, I'll add sulfur or sulfur based compounds like S2Cl2 like that, etc. What will happen? Very few percentage. If you take our car tires and all, you'll add up to 2 to 3% carbon is added. Their carbon is the doping material, carbon black, which also acts as a pigment. మన కార్ టైర్స్ బ్లాక్ కలర్ లో ఉంటాయి. ఎందుకు? పిగ్మెంట్ ఏంటి? కార్బన్ బ్లాక్. That carbon black is also a filler and helps for the purpose. Okay, and the percentage of sulfur in that is 3%. 3% sulfur is present in car tires. So what will happen? Some small amount, at few places, what will happen? There is vulcanization. What will happen in vulcanization? The pi bond here breaks, okay, and between two chains, the sulfur gets incorporated. Dini pi bond, dani pi bond break, sulfur gets incorporated. That is vulcanization. Again, here there is normal pi bond. But at few places, this sulfur molecule will break the pi bond and will get incorporated. This rubber is called as vulcanized rubber, and the process is called as vulcanization. Now, what vulcanization will do? It will give the required rigidity to rubber. Take, for example, tire cheyali. Muddala unte em chestam? It's a most composite material. Em chestaru? They'll take some 3% sulfur, okay, and they'll add carbon black as a filler. Okay, so that makes the real engineering material from the rubber. Okay, and hence is vulcanization. This is all are the prerequisites which you need to know for our discussion. See, by chance, if I take a class on in the regular time only on Monday, I'll finish. I might take leave on one day, Thursday probably, I don't know. So please do join. If I take a class tomorrow, will you join, or you're reluctant for a class, 1 hour class? I'm little worried whether I can finish the syllabus. And I'm really a slow person that way. If you say no, no problem. A day before your exam also, I'll take an extra class and finish off my syllabus. I'll put a PPT presentation, that's it. But that's not the idea, is it not? So, anyways, I'll message you tomorrow. Okay, I'll leave, and I hope I spoke about the natural rubber, the change in the functionality of butadienes to what is 1,4 addition, and what is vulcanization of rubber. These are the words which you need to know when we are talking about the rubbers. And that's it. The class is over. But tomorrow, what you have in your syllabus is there are 3 things which you need to study under elastomers. In subject of for you, what are included are these are synthetic rubbers. Synthetic rubbers, they undergo copolymerization. And what you have in your syllabus is example, Buna S rubber, that's there in your syllabus. Buna S rubber, which is a copolymer of 1,3-butadiene plus styrene. This is 75%, that is 25%. Again, copolymerization. Okay, so that is example 1. Example 2. This is just for as a running notes. What you have in syllabus is butyl rubber. Okay. You have isobutene, 95 to 97%, plus isoprene. One second. Isoprene is 3%, I suppose. Just hold on. I'll give you the percentage clearly. Butyl rubber with small amounts, 1 to 5%. Yes, 1 to 5% isoprene. 1 to 5% ante that is here also 3 to 5%. Okay, will be isoprene. That's the copolymerization again. The third one you have in syllabus is silicone rubbers. Silicone rubbers. Okay. These are actually organic silicones with SiO bonds. Okay. These are silicone hydroxides. That's the point. Okay. That concludes the class. I'll just quickly take the attendance in 1 minute. And you can leave. Thanks that you have joined for the session. In spite of this, where is my book? Okay, please give me your attendance. 61.